Hey all, happy Monday. So I just wanted to go over a few things today. It's going to be a relatively short video. Not a lot kind of going on. We're near the end. Today's mostly just kind of wrap up, but there's a few things I want you guys to know about. Number one, first things first is if you guys haven't finished your projects yet, just try and make sure that you guys get those in as soon as possible, ideally by Thursday at the latest. Excited to kind of go over, watch your videos, see you guys talking about the solutions that you guys came up with and how you ended up coding them. Hoping that it went kind of smoothly and worked out well. On either Wednesday or Thursday, depending on which class you're in, either A day or B day, what I'm going to try and do is this next class period, so the final class period. Friday, of course, we're having like an assembly, so they're telling us kind of not to give you guys classes that day. So either that Wednesday or Thursday, if you're an A day or B day, I'm going to try and do just kind of an all-class meeting, just like a chance to see your guys' faces. So we're going to do a Google Meet and just kind of hop on there and just kind of hang out and chat and kind of catch up about the year and what's going on and what your guys' summer plans are and see all that kind of stuff. So that's my goal. I'd like as many people who can log on to those time periods to come to class as can. The Google Meet link for each class, if you just go to your class page, it's right there. You can just kind of click at the top. So I will be there at these times for those classes and hope to kind of see you guys there. One thing I recommend doing is downloading this this grid view extension for Google Meet. That way you can kind of see everybody in class, so it's not just like you can only see like who's talking or whatever. You can actually see everyone. So if you guys haven't done that, I recommend doing that. And hoping to see you guys there. I think it'll be kind of a fun thing to just see you guys and hang out. What I wanted to talk about today is just a little bit of like an end of the year wrap up for what we did kind of in engineering and specifically looking at this quarter. So I started off this quarter just with the question, kind of how are humans similar to and different from robots, with kind of our inputs and our outputs, our sensors and our actuators, and how do you guys kind of think about that? And I kind of want to take a second, and part of this was brought about just kind of by my own like thinking about, kind of what's a cool way to tie and wrap up everything that we've talked about this year. And so if we look back at what we kind of did, the first quarter we talked about statics and materials. Second quarter was mechanics and simple machines. Third quarter was work, energy, and circuits. And the fourth quarter was kind of this coding and machine control. So statics and materials is all about just creating things that are structurally sound, using kind of the right materials for the job, depending on the properties that you're looking for. And then the second quarter was all about, essentially how we can use machines and mechanics to design things that are moving, right, that are kind of changing their position, that are using energy, right, and transferring energy in particular ways to do a certain task. Quarter three was essentially how do we kind of harness that energy through the generation of power and power plants, and then how do we kind of direct that energy using circuits, either simple or complex, to kind of get jobs done. And then quarter four was kind of about, really kind of complex circuits where we can actually kind of code for things to do this. So we actually have kind of this new language that we can use computers to essentially turn on and off switches and send signals, electrical signals to certain parts of a machine, for example. So all of these are of a big importance for engineering and just kind of any designed or built thing that you see in the world. Materials, I will still say, is like probably one of the most important like pieces of them all, is just understanding like how do we choose different materials for different things. Like that's a big deal right there. It's like the creation of new materials, and then just making sure that you're choosing the right thing for the right job. Statics, all I'll say is the biggest thing you can remember is things being kind of in joist versus plank orientation, right? If you want something, if we think of how much something's going to bend, right? If it's taller than it is wide, it's going to be more sturdy. And if it's shorter than longer, it's going to be more sturdy. So just kind of simple things like that. I did want to talk a little bit about kind of go and build on this comparison between humans and robots and machines. And I do want to talk about like the engineering of your body as a whole. So if you think of like the human body, like you guys, right? And everything that we've talked about this year, right? How does that kind of apply, right? How are kind of humans kind of like feats of engineering? And if we think of like the statics and the materials, the first quarter, first of all, it's like your body has like these different kind of building blocks, these different kind of base kind of compounds that you guys are built out of. Simple proteins, muscle tissues, collagen fibers, things like that. Just simple molecules, different types of molecules. Think of bone, for example, and just speaking of statics, it's like what kind of gives you your structural support that allows you to stand, that allows you to walk. Well, that has to do with a lot of the kind of statics, your bones themselves, right? The density of those bones, the kind of shape of those bones is very much influenced by the loads that they're under, as well as the joints, right? The joints that connect your bones together. So it's kind of cool in that way, right? The specific shape of them, how they're kinda, if you look at like a femur, for instance, one of your leg bones, it's wider at the top at the connection, and it's wider at your knee at the base connection, and then it kind of tapers in the middle. It's like, well, why does it do that? Well, that all has to do with how it can actually support that load. And since it's under compression, right, it doesn't necessarily need a really thick kind of middle. It kind of has this nice kind of tapered shape that allows it to still be strong while kind of reducing the overall weight of the thing, which allows us to be more mobile, right? So just thinking of the materiality and the structural stuff within us that allows us to work. If you think of the mechanics, right, looking back to our joints, right, at the wrist, the elbow, hip, knee, neck, you name it, and then also just kind of the muscular system, right? How does that allow us to to move in efficient ways? If you think of like our tendons with our muscles, you can actually feel like right here there's a tendon, and what that does is that's attached to your bicep muscle, right? So as your bicep muscle contracts, right, it pulls on this tendon, which lifts your entire forearm. Now the pivot is actually down here, right, but it's lifting at this point right here, right? So what we have is we have our fulcrum, we have our kind of input force, and then we have our resistance force lifting our whole arm. So when you actually do that, you're using a simple machine. You're using a third-class lever, right? Pretty straightforward to actually do that and using your muscles, right? So every single motion, no matter how complex we can analyze, using kind of like the simple machines that are within your body, using those mechanics. I was actually looking up some cool stuff recently about how people are creating like robots and different types of things that have these walking motions that are similar to the pattern that we make, where we kind of like stride backwards and then we lift up our foot and then stride forwards, right? So it kind of makes this weird like triangle shape. I'll kind of like draw it in there, right? So you kind of stride backwards, lift up your foot, stride forward. So it makes kind of a shape like that. That's kind of your tread shape, the shape that your foot actually takes. And people are designing these robots where it has a leg, and based on kind of the joints of that leg can take a particular walking motion, and it can actually walk. So we're actually creating walking robots that can be powered by a simple motor, which is pretty cool. So that's, you have the actual body itself, which is making sure it's rigid, it's got the right materials, it's got the right joints, it's structurally stable, and then you have these kind of the right joints and mechanics to actually make it kind of recreate kind of human motion, just as we do. It's like we have specific joints and we have specific muscles that pull in different ways to make us move. And then if we think of like the energy capture and transfer that our bodies use, right, we have to get our energy from eating things, right? So you guys need to eat every single day. It's a very important kind of thing. You need to get a source of energy, and then your body actually uses that energy, right? In your muscles, you break down that glucose to produce ATP, and you use that ATP to actually fire your muscles and to do all sorts of other microprocesses in your body at the cellular level or at the level of molecules, right? Using that ATP to actually, control diffusion within cells, to actually control and move and open synapses in your nervous system. You use that energy to fire your muscles, right? So that's all. How do we collect that energy, and then how do we process it and transfer it? And then if we think of like the circuitry within our bodies, the nervous system, right, allowing us to actually kind of communicate and tell our bodies where to fire muscles or where to move or what things to do, right? And then this last piece that we talked about was this coding, and so you have this computer, which is essentially this very complicated circuitry. So if you think of simple circuitry as our nervous system, right, this series of nerve cells that is wired kind of through our whole body, connected to everything, and that's relatively simple circuitry. And then within our brain, right, we still have those same neural cells, those same neurons, but they are wired and attached and arranged in a much more complicated way that allows for different kind of pathways to be activated. That's the same with the computer. A computer is just simple circuitry gone complex, right, to a way to where we can actually control like pathways, right? Using simple inputs or simple triggers, we can actually control, right, where electrical impulses are sent. And so that's what we did in this last unit is we essentially were looking at how can you actually code a robot? How can you tell it what to be, what to do, given certain inputs? If it's sensing certain things, how can that trigger certain outputs, and how can we tell it what to do? And so, long story short, right, you could actually build like a human-like kind of thing, or really not necessarily even human, but just like a sentient or a living kind of creature, right? Using kind of what we know that is structurally stable, that can live, that can move, that can take energy in and give it off. If you think of like being energy self-sufficient, right? If you had a being that's kind of powered by solar, for example, or by wind, you could use that energy to power kind of its circuitry to kind of take in sensory information and move around. It's really pretty incredible how we can actually do that and how we can create those kind of things. So that's kind of one example where it's like we are, essentially engineering ways to create ourselves, things that can do the things that we do. I'm attaching kind of one video, it's actually pretty dark, but it's kind of cool. It's by this channel called Kurzgesagt, which stands for, it's German for in a nutshell. Really great videos. I recommend watching like all of them. You can get stuck on their channel for hours. But it's a little dark. It's talking about like kind of why machines and automation, kind of some of the impacts that those actually have on society as a whole, and kind of talking about how they can replace humans, which is pretty interesting, and how they're getting more and more, our coding and those machine brains are getting more and more human-like. So it's kind of crazy. But that's not the only purpose of engineering, is to do that. It's also to kind of address and solve kind of these different problems that we face and try and make our lives better, right? And even just to like build simple things, as like I was up at my cabin in Colorado and just, daydreaming about the things that I'm going to build and the things that I'm going to add up there, and to create a space for myself, right, to kind of address some of my problems and some of my interests. Thinking about, in physics, we're just talking about sound and talking about making speakers. And it's like, that's a fun engineering problem, is how can you actually make something that can play music, right? Something that brings humans great joy, right? How can you solve problems using engineering, such as, what we're facing now with the whole coronavirus? I know there's a big shortage of medical equipment, and Mr. Owen was actually, featured in the news the other day he was actually making kind of these protective face shields using the 3D printer. So how can you kind of come up with, how can you use these tools that you guys have learned to come up with creative solutions to kind of new and interesting problems? Thinking about kind of global warming and climate change, what are things that you guys can do, that you guys can design or engineer, create, build to kind of address and tackle those problems? Creating and harvesting energy to use for everything that we use, electricity for. How can we come up with new ways to do that? How can we use existing technologies and implement them in ways that are, useful to people? And then how can we use this kind of coding to kind of, make it so it's easier for us, right? So we can hand over some of the tasks to the robots. So there's things to think about as you guys kind of pursue engineering and pursue your life in general, right? How can you guys use what you've learned in this class and use kind of engineering as a tool to kind of make the world a better place? That's the idea. And one thing that I want you guys to think about, and that's these last couple of videos that I'm going to link, this is another Kurzgesagt video, but why beautiful things make us happy. So just thinking about beauty and aesthetics in your guys' design. This is something that I think can be really underrated sometimes, is when people design or they make things, they don't necessarily always take into account the beauty and the fact that does actually play a big role in how humans perceive it and our overall happiness and the usefulness of something. So that's a really cool video. I'm a big fan of just kind of aesthetics in general, so definitely check that out. And then kind of as an example of that, there's this kind of engineer and artist, and this is a project looking at, it's using actually a little bit of biomimicry, some mathematics, some physics, and it's called Creating the Never-Ending Bloom, and it's a really cool kind of little project and passion that this guy's kind of been working on, and so that's a cool video to check out. So a few videos to check out, a few things that I want you guys to just think about, and as far as what we've learned this year, and as far as kind of what holds for you guys in the future. So I hope to see you guys on either Wednesday or Thursday. There's one thing I want you guys to check out. I just posted a question. There it is, boom. I'm gonna post this question here. And I just want to get some feedback from you guys about what are things that you guys remember this year, what are some of your favorite things, and things I should maybe add or change or do differently. So, yeah, hope to see you guys next time. That's all for now.